Hi everyone and welcome to the TDE Happy Math Hour, weekly interactive math reviews for Math 1314 and Math 1324, hosted by Yvette Chuca, Ruben Carrizales, and Mr. Alberto Azasi. So today's session is going to be on the standard form of quadratic equations and graphing equations. We're also going to have a session in another room and the link will be provided for you in the chat for Math 1324, which will be covering, give me just a moment.
Converting exponential functions to logarithmic functions.
Thank you so much, Ms. Chuca. So without further ado, here is Ms. Chuca.
Hello, everyone. As Ms. Patricia said, we are going to be separating today into two groups. If you are taking 1324 or NCBM 0124, then you're going to want to go ahead and click on the link and go to that other room with Mr. Isasi. And then for all the 1314 students and 314 students, we're going to stay here and look at examples on the standard form of quadratic equations and graphing. And at any time, if you have any questions, please feel free to let us know so that we can address your question at that moment of time. So we'll get started. Excuse me. So in chapter 1, we started to look at different equations, and we looked at several ones. We look at linear equations, quadratic equations, and so on. In this chapter, we're going to be looking at quadratic functions, but then we're also going to be looking at anything that has a exponent or a degree that is greater than 2. So we're going to be looking at different polynomials. So for the quadratic equations, we have the first one, f of x equals ax squared plus bx plus c. We say that this is in a general form. And then the standard form, and sometimes we also call it the vertex form, but our textbook calls it the standard form, at least for this author. And this one looks like f of x equals a times x minus h squared plus k. And so we're going to take a good look at going from the first form into the second form. And then from there, we're going to look at different characteristics of the graph and talk about those as well. Okay, so here's the definition of a quadratic function. We know that it's quadratic if the exponent, the highest exponent is a 2. Anything greater than a 2 is going to be a different type of polynomial. And the shape of the graph is a U shape here, the parabola. And then in 1.6, we also talked about f of x equals x squared being the parent function. So with their parent function, we can use this parent function to graph any other function that's related to the quadratic family. And so again, this is an example of a polynomial with degree 2. Okay, on the left side, we have the general form. And then on the right side, we have the standard form. And so one of the things that we want to look at is how do we know when a graph opens up and how do we know if a graph opens down? And so if you notice here, the number in front of x squared, we say it's a. If we look at this example here, the number in front of x squared here is a positive 1. And anything that is positive or greater than 0, the graph is going to open upward. Okay. But if you look at the right side, you can see that we have a negative here. And so anything with a negative or anything less than 0, the graph is going to open downward. The bottom part of this parabola here on the left side is, we call this point here the vertex. And we also say that it has a minimum. So anytime you're working with a word problem, if it asks you to find the minimum and it's a quadratic function, then what they're asking you to do is to find the vertex. And the vertex can be found using this formula here. But then if it's in standard form, you can also find the vertex by looking at, let me go ahead and go back, at the h and the k. So here in the standard form, if you notice here, you have a minus h. So to get the vertex, it's going to be the opposite of minus h, which is positive h. And then your k, which is going to be just your k. And we say that this top part of the parabola is a maximum point of your parabola. Now notice that both of them have a green dotted line. And so this green dotted line is called the axis of symmetry. And the axis of symmetry is always going to be your x-coordinate of the vertex. So in this case, your x-coordinate of the vertex is h. So we say the axis of symmetry is equal to x equals h. And on the left side, our axis of symmetry is going to be negative b over 2a. And again, the axis of symmetry is a line that cuts your parabola in half. And so it's similar to the reflection that we talked about in chapter 1. In a little bit, we're going to be looking at all these in more detail. Okay, so one of the reasons why we want to go from the general form to the standard form is so that we're able to find the vertex a little bit easier and quicker. And so again, if it's in standard form, then your vertex is given by hk. So to be able to convert from the general to the standard, then we complete the square of the quadratic function. I'm going to show you here how to complete the square just using variables, or just using a, b, and c. If you notice here, I have no numbers. But the good thing about this is that at the end, it kind of produces a formula for your vertex that you could use from today on, okay? But don't get overwhelmed with this since it has no numbers. In a little bit, we'll work it out with numbers, okay? But the first thing you want to do is make sure that your quadratic function has a 1 in front of the x squared. So if you have something that is not 1, we're going to factor it out. So if you notice here, first I'm going to group my ax squared and my bx term together, and then I'm going to put the c by itself. So then I want to factor this a out because I need to make sure that in front of x squared you only have a 1. So if I factor out the a, essentially what you're doing is you're just dividing by a. So a divided by a is going to be a 1. So we factored it out. And then for the b, if we factor out an a from here, one of the ways to do that is if it's kind of like we're just dividing by a, right? Because if you multiply a times b over a, you end up with a b. Okay, so then this is where we're at. Your second step is going to be to take half of b. So we're going to take half of b. Remember that b is the number that is in front of x. So in this case, the number in front of x is b divided by a. So if I take half of that, that just means to divide by 2. And so I end up with b over 2a. So our third step is going to be to square it. Let me go back here one more. So whatever you get after you take half, then you're going to square it. So we're going to have b divided by 2a squared. And we end up with, I'm going to leave it like that. So that way we can see the formula at the end. But whatever you get here, you want to add it and subtract it inside of that parentheses. And why do I want to do that? Well, if I add and I subtract something and they're the same thing, then I end up with 0 here. So we're not changing the problem, we're just making it look different. Okay, so now we want to get rid of this negative b over 2a squared. So we're going to factor that out of the parentheses. But in order for me to factor it out, I have to worry about the a that is out here. So in order for me to factor it out, I'm going to have to multiply this a to my term over here. Okay, so that's what I have right here. A times negative parentheses b divided by 2a squared. And so that's going to be factored out. And so what I have left in the parentheses is what we're going to factor. It becomes a perfect square. So this information here, we can factor it into 2 parentheses. And then we get x plus b over 2a times x plus b over 2a. And then this is still the constant that we have that we're adding and subtracting together. Now, since this parentheses and this parentheses is the same, I can write it as x plus b divided by 2a squared, and then I'm going to have this here. So now this is in standard form. So my h is going to be the negative b over 2a, so it's the opposite of what we see here. So negative b over 2a, and then your k is going to be all of this over here. So this would be your k. So if you have this right here, you can always find the vertex using this formula here. But there's an easier way to do that. So for now, we'll come back to this in a little bit. But the best way to understand the steps is going to be to work it out with actual numbers. And so I'm going to go ahead and do here. The instructions are to write this equation in standard form. And then we're going to identify the vertex and the axis of symmetry. So the first step is to group x squared and 2x together. So notice that I grouped them here and I left a blank space. And then I have my plus 1. The second step is I'm going to take the number in front of x, which is 2, and I'm going to divide it by 2 because I'm taking half of it. So 2 divided by 2 is equal to 1. And then whatever answer I get here, I'm going to square it. So 1 squared is equal to 1. So this result, we're going to add it into the parentheses right here. So I have my positive 1, and then again, I'm going to subtract the 1. And you can see here, 1 minus 1 is 0, so we're not changing the problem. So our next step is, well, we don't want this negative 1 in the parentheses. And so we want to take it outside. And so in order for me to factor out this negative 1, I have to ask myself, is there anything outside the parentheses other than 1? And if there is, then I'm going to have to multiply it. In this case, we only have a positive 1, so 1 times negative 1 is just going to be negative 1. So I write it on the outside here. And now I have this parentheses, which is going to be a perfect square. So my goal is to factor it into two parentheses, and I'm going to get x plus 1 times x plus 1. Now there is a shortcut for this. So let me tell you what that shortcut is. This number here, plus 1 and plus 1, the number that goes here is always going to be that half that you get when you take your b and you half it. So like here we had 2, and half of 2 was 1. So this 1 is what's always going to be used here in our parentheses. Why? Because 1 times 1 is 1, 1x times 1x is 2x, and so that's going to be the factors. Now that I have two parentheses that are the same, I can write it as x plus 1 squared, and 1 minus 1 is 0, and so this is going to be our equation in standard form. So from here, we can take the vertex. So our vertex is h. So h is what's in the parentheses, so I have a plus 1. And so h is going to be the opposite, so I write negative 1. And then I have no k, so k is going to be 0. My axis of symmetry is always your x coordinate. In this case, x equals negative 1. Okay. So we have about 2 more of these because we want to make sure that you understand the steps here, but also give you different types of examples. So here, the x squared didn't have a number in front. Notice our next example, it does have a number, okay? So again, the first step is group the first 2 terms together. So we have 2x squared plus 8x. And then I always leave a gap because I'm going to add and subtract some in that parentheses. And then I have plus 7, okay? Next, we want to make sure that the number in front of x squared is a 1. So we need to get rid of this 2. And the best way to get rid of it is to factor it out. So I'm going to take this 2 and I'm going to bring it outside of the parentheses. And if I do that, then I get 2 on the outside. I have x squared. Then I have an 8. So if I factor out a 2 from the 8, I end up with 4. And if you're not sure if you did this part correct, just multiply it out. 2 times x squared is 2x squared. 2 times 4x is 8x. So you can see we would get the same thing. And then I have my plus 7. Okay. So the next step is to take half of b remember that b is going to be that number in front of x. So half of 4 is going to be 2. So 4 divided by 2 is going to be 2. And I put the 2 in red because later on at the end, this number 2 is going to be what we use in the parentheses, okay? So once you take half of it, your next step is to square it. So we're going to have 2 squared, which is going to be 4. So now our next step, can anybody tell me in the chat what would be our next step? What do I do with that plus 4?
Divide it by
Okay,
2
so
and square it.
yeah, so we divided by 2 and we squared it, so that was correct. And now we're going to go ahead and add it in the parentheses, but I'm also going to subtract it. So notice here I went ahead and added and I subtracted it. But we don't want this negative 4 here. We want to get rid of it. And so you might be asking, well, you just put it there. Why are we going to get rid of it? Remember, the whole thing that we're doing here is we're basically manipulating our original equation so that it looks different. But in order to do that, we can only add the number 0 without changing anything. And that's why we have the 4 and the minus 4. So to get rid of this negative 4, I have to worry about the 2 in the front. So I'm going to multiply them together. So 2 times negative 4 is going to be negative 8. And that's the only way that I can bring it outside of the parentheses. Did you have a question?
Yes. So if the 2 and the 8 were negative, then does the number outside become a resulting plus instead of a negative?
If this was negative and this was negative?
No, if the 8 was negative, it was 2x squared minus 8x.
Okay, you could factor out the 2, but the 4 would be negative here, right?
Mm-hmm.
So you would have a negative 4x right here.
Mm-hmm.
And then you would take half of negative 4, which is going to be negative 2. But when you square it, it becomes a positive 4. So you would still end up with 4 and minus 4.
Okay.
Okay. So now that we have our negative 8 outside, whatever's in the parentheses here now is a perfect square. And your goal is to write it into 2 parentheses. And remember that 2 at the, excuse me, that 2 at the very beginning that was in red, that's going to be the number that we use here. So we have x plus 2 times x plus 2 will give me x squared plus 4x plus 4. And then you still have the 2, and negative 8 plus 7 would be a negative 1. So since I have 2x plus 2's, I can write it as x plus 2 squared. So now you can see that this is in standard form. And our vertex is going to be the h, which in this case we have a positive 2. So our vertex would be a negative 2. And our k is a negative 1. The axis of symmetry is going to be the x coordinate, which in this case is negative 2. Okay, so we'll try one more. That way we can make sure we get the steps down. So again, we group the first 2 terms together, and then we want to factor out of 5. So if I bring this 5 out, I'm going to end up with 5 times x squared is the 5x squared. And then the 15, if you divide this by the 5, it gives you the 3. So 5 times 3 is the 15x. I leave my little gap because I'm going to add and subtract something in here. Then I have my negative 5. Any questions on the first step? So which number, well, I have it there on the slide. I was going to ask you which number do I take half of, but we're going to take half of our 3. So here's our 3. And half of 3 means to divide by 2. So 3 halves divided by 2 is 3 halves, or 3 divided by 2 is 3 halves. And then this number here, we want to square it. So 3 halves times 3 halves is going to be 9/4. Okay. So we're going to add 9/4 and we're going to subtract 9/4. And then, of course, we still have the minus 5 here. So you want to get rid of this negative 9/4. So you want to ask yourself, is there anything in the front? And there's a 5 here. So the first thing we need to do is multiply the negative 9/4 times the 5. and I went ahead and put it down here. Negative 9/4 times 5 is equal to negative 45/4. Okay, so once you multiply, you can put it on the outside here, which I put it right here. And I'm going to simplify now. So inside, trying to factor this could be difficult because you have a fraction. But don't forget that shortcut that I mentioned earlier, which was the number that you get for b, which is 3. Whatever you get when you take the half, that's going to be the number that goes in the parentheses. So 3 divided by 2 was 3/2. And so I'm going to have a positive 3/2 and a positive 3/2. And that's going to give, that's the factors of this quadratic part of the function here. And then in order to add or subtract the fractions, we need a common denominator. So this 5 needs a common denominator of the 4. So I'm going to have negative 20 over 4, which is 5. And then 45 divided by 4. Since they're both negative, I subtract them. So negative 20 minus 45 is going to give me negative 65 over 4. So my vertex is going to be negative 3/2 and negative 65/4. So your axis of symmetry is negative 3/2. So again, if you ever run into a situation where you have a fraction here, you can just come back to what the number that you got when you took half of it. And that's really what's going to go in the parentheses here. Okay. So this, I'm not going to go over this part too much, but remember at the beginning, we came up with a formula. After I did I found the standard form using just general numbers. So you could use this formula here to help you write your equation back in standard form. And so A, remember, is the number in front of the x squared, and then B is the number in front of x, and so C is going to be your constant. So if you just plug in all those numbers here and simplify, you're going to end up with the same answer that we got in the previous slide. So those are for people who rather use a formula, then this would be what you could use here. Okay, so the next example is still writing the equation in standard form. But if you notice here, we don't even have an equation, right? We just have the parabola. So somehow we need to come up with the standard form. And although we could probably use the parent function, and we noticed that it got shifted to the left and it went down, but then we would have to figure out what a is in front of that parent function. So there is a way for us to do this. And so these are the things that you're going to need. You need to know what the standard form is. That's just the f of x equals a parentheses x minus h squared plus x. You need to have a vertex, and you need at least one additional point. So they give me the vertex here, and they give me an additional point. If they don't give you an additional point, you could use any point you want as long as you know what the point is. So like I could have used -2 and 0 instead of 0, 0. But I wouldn't want to pick this point because I don't know what that is. So always just make sure you pick one that you know for sure that that's the point. Okay, so our vertex is -1, -1, and then the point we're going to use is 0, 0. So what we're going to do is plug it into the standard form of the equation. And so for this additional point, we're going to call it x and y. Okay, so let me go ahead and just put that there. I know it's on the side, but let me put it right underneath because it makes it a little bit easier. So this is your x, and this is your y. Okay. So what we're going to do is plug that in. So we have f of x. Well, f of x, remember, is the same as y. So our y here is 0. So I'm going to plug in 0. My a, I don't know what a is. X is 0. So I plug in 0. Minus h. H, again, remember, this is your h here in the vertex. So we get -1. And then your k is -1. So we're going to simplify so that we can solve for a. So I get 0 is equal to a. Negative, negative is +1, and we're still squaring it. -1. 1 squared is 1. In order to solve for a, I'm going to add 1 on both sides. So I get 1 is equal to a, 1. And then I'm going to divide by 1. So I get a is equal to 1. So that's my answer for a. The problem didn't say to solve for a, but we can use this to write the standard form. So that would be the last step here. So our standard form is f of x is equal to a. A is 1. And then I'm going to have x minus h. H is the negative 1. And then k is the negative 1. So simplify a little bit here. Negative negative is a positive 1. And so this is going to be our standard form. You don't have to write the 1 again. If you do, it should still count it correct. Okay. So I believe I might have another one here. But if you notice, they don't give you the graph, but they still give you the information that you need. You have the vertex and you have a point. So again, I always like to start by writing the standard form. And then I like to identify my points. So this is my h, this is my k, this is going to be my x and my y. So I'm going to plug those numbers into the parentheses. So y is 3, a is unknown, x is 0, minus h is negative 3, and then my k is negative 15. So we're going to simplify. So in the parentheses, we have 0 minus negative 3. So that's going to be a positive 3. And then we're going to square it. So 3 squared is 9 minus 15. I'm going to go ahead and add 15 on both sides. So 15 plus 15 here. And then plus 15 here gives me 15 plus 3 is 18. And then we're going to divide by 9. So we get a is equal to 2. So I plug those numbers in here. So here's my a is 2. X minus h. Again, h is negative 3. And then k is negative 15. Negative negative is a positive 3. So I end up with my answer, which is here f of x equals 2 parentheses x plus 3 squared minus 15. Okay, so that is how we could write the standard form given the vertex and any point that we might have. Okay, so in the next slide, one of the things that you're going to be asked to do for the rest of this chapter is to find the zeros. They use the word zeros quite a bit, but the zeros have other names. These 4 names are the same thing. So we call this point right here the x-intercept, the zero, roots, and solutions. So if you ever hear a problem or you read a problem and it says find the solutions, they want this point right here. Find the roots, find the zeros. They're all talking about the point where the graph crosses the x-axis. And in order to find those zeros, we let y equals 0 and then we solve for x. Okay, so there's different methods to solving these quadratic equations. Number 1, you can use the square root property. That property cannot always be used, and I'll explain why in a little bit. And then the factoring, you can't always use factoring because not everything is factorable. And then the quadratic formula, that one works all the time. So depending on the problem, then I decide on a method depending on what the problem looks like. Okay, so, and the last thing is not all parabolas have x-intercepts. In other words, you could have a parabola that looks like this, where you have your xy axis and the parabola might be up here. And so it's never going to cross the x-axis. So we would say that it has no real solution, or it could be down here. Okay, so they're not always going to cross this x-axis. All right, so let's look at some examples. So if we have f of x equals x squared minus 4, and they ask you to solve or to find the zeros, the first thing you want to do is let y equal 0. So here's my y equals 0. And then I'm going to go ahead and add 4 on both sides. So plus 4 here and plus 4 here gives me 4 equals x squared. In order to solve for x, I can take the square root, and I end up with x is equal to the square root of 4. The square root of 4 is going to come out as a 2. But again, it's a plus or minus 2. So my solutions are x equals 2 and x equals -2. Okay, so here I could use the square root property. You can use it anytime that you don't have that middle term ax. If you only have an x squared term, then this property will work. Okay, so we look at this one here. The first step is let the y equals 0, and then I have my information here. So in order to do the square root, I have to leave the square by itself. So I'm going to get rid of the 27 by adding 27 on both sides. And so I get 27 is equal to 3 parentheses x minus 4 squared. But the squared part of it is still not by itself, so we need to get rid of this 3. And I'm going to get rid of the 3 by dividing by 3 here and dividing 27 by 3, which is 9. And now x minus 4 squared is isolated, so I can take the square root on both sides. And the square root and the 2 become a 1, or as some people like to say, they cancel. And so we get x minus 4. And then the square root of 9 is plus or minus 3. We're still trying to solve for x, so I'm going to add 4 on both sides. And I end up with 4 plus or minus 3 is equal to 7. So 4 plus or minus 3 can be simplified as one answer would be x equals 4 plus 3, which is 7. And then the other is x equals 4 minus 3, which is equal to 1. Okay. Now for factoring, same idea. The y, we want to make it equal to 0. And then you want to factor this. So if you are having, so factoring is a quick way to do this, but you don't want to stay stuck with factoring. I usually tell my students and even myself, if I cannot factor a problem in the first minute or 30 seconds, then maybe it's not factorable. I'm going to go to the quadratic formula. But in this case, it is factorable. So for -6, we did have a factoring session 2 weeks ago. So if you're struggling with factoring, I encourage you to watch that video. And somebody will put the link to our YouTube channel with all the videos there. And so here we get x minus 3 times x plus 2 is equal to 0. So we set each parentheses equal to 0, and then we solve for x. So x minus 3 is equal to 0. Add 3 on both sides, so we end up with x equals 3 and x equals -2. And then the last method is the quadratic formula. It's not, it always works, but I do see students make mistakes on the algebra part of it. So sometimes factoring might be a little bit easier, but everybody has their own preferred choice. Pick whichever one works for you and use that one. So here, this is a quadratic formula. And the number in front of x squared is your a, and then the number in front of x is your b, and then you have your c as your constant. So we plug it in. So we have negative b. So we're going to have negative, and then b is a -2, and then plus or minus the square root of b squared, -2 squared, minus 4 times a. Remember, a is 1, and then our c is -8. So we simplify. Negative and negative is a +2. Negative squared is a +4, and -4 times 1 is -4 times a -8 is a +32. So 4 plus 32 is 36, and then the square root of 36 comes out as a 6. So then here, if you notice, 2 divided by 2 is 1, and 6 divided by 2 is 3. So if we separate these, then we end up with x equals 4 and x equals -2. And so that's going to be our solutions. Okay. If you end up with a negative in the square root, then we say that there's no real solution. And so the graph of it means that it's somewhere up on the x-axis, like above the x-axis or below the x-axis, but it's never going to cross it. Okay. So I wanted to just kind of review these 4 different methods, because in the next section and the 2.3 or 2.5, you can use these methods to help you solve the equations. Okay. So let's look at 2.2. Okay, so what is a polynomial? So we just said that a quadratic function is a polynomial, but there's more than quadratic functions, right? So in order for something to be a polynomial, the graph has to be continuous. In other words, for example, this is a continuous graph on the left side because you don't have any breaks in it. On the second picture, if you notice, the graph has a break, so you wouldn't be able to draw this without lifting your pencil. So if that happens, then it's not a polynomial. Okay, let me go to the next slide. So one of the big things in section 2.2 is determining the behavior of a function. Okay, and what they want to know is, what is this end behavior? So if you look at this graph here, on the left side, this graph is going up, and on the right side, this graph is going up. If you look at the second one, on the left side, the graph is falling to the left, but it's also falling to the right. And then the third one, the graph is rising to the right, and it's falling to the left. Okay, so we want to know, when does that happen? And so if you open your textbook, you're going to see several definitions there telling you what the end behavior is. But I always encourage my students, if you remember these four graphs, then that's always going to help you determine the behavior. Okay, so for example, the first one is f of x equals x squared. And in order to do this, you're going to need to know what the degree is. Remember, the degree is going to be whatever the highest exponent is. So if you have x squared, the highest exponent that you see here is going to be 2. And the number 2 is even. And then you need to look at the leading coefficient. The leading coefficient is the number in front of the term that has the degree. In this case, the number in front of x squared is 1, which is positive. So if you have a function that has an even degree and it's positive, then we say that the end behavior is going to be that it rises to the right and it rises to the left. If you have an even degree with a negative coefficient, then the graph is going to fall to the left and it's going to fall to the right. But if it's an odd degree, like in this case, x cubed, there should be the degree is the 3, is going to be odd, and the leading coefficient is a 1, so it's going to rise to the right and fall to the left. And then on the last one, again, this should say degree is 3, and that's odd, so it's going to rise to the left and fall to the right. Okay, so no matter what equation I give you, if you know the degree and you know the leading coefficient, you can tell me what the behavior is. For example, here's a whole bunch of them, right? So if we look at A, the degree, you have a power of 8, a power of 2, a power of 5, and a power of 1. And then you have a power of 0, x to the 0 here. So your degree is the highest exponent that you have. So my degree in this example is going to be what? What is the highest degree? 8, right? So we say that the degree is going to be 8. Now the leading coefficient is going to be located in front of that term. So in this case, it's going to be a 3. Okay, so since we know that we have a degree of 8, is that an even or is that odd? So that's even, right? So it's either going to be this first graph or the second graph. And then the 3 is positive, so it's going to be the first graph. So the behavior is going to look like this first graph. So we're going to write that the degree is, well, we already said that. So the graph will rise to the right and it's going to rise to the right, to the left. So it's going to look something like this. Okay, it's not quite going to look like that because, for example, the graph might look something like this. I'm just going to make it up here because I want to make sure that you don't think it looks like a parabola. The graph could be something like this. All we know is that it's going to go up on this side, and we know that it's going to go up on this side, but we have no idea. It could be doing something like this, and then it could come back over here. We have no idea what happens in the middle, okay? But we will in the later I think I might get to an example in this session, if not next week. We'll figure out what happens in between, okay? Okay, the second one, the degree is 3, and the leading coefficient here is going to be a what? So I have it wrong here, but what is the leading coefficient for this one here? So the degree is 3, and the leading coefficient is not 3, but it's a -1, okay? So my behavior, it's not going to be the first graph or the second graph. Now we're looking at the third and fourth graph. So if we have a degree that is odd and the leading coefficient is negative, then that means that our behavior should be like the last one. So we would write the graph will rise left and fall right. And on your web assign, it'll be multiple choice, so you can select which behavior it is. Okay, so let's try the next one. X to the 6, the degree is going to be, we have x to the 6 plus 3x to the 5th minus 4, 8 plus 8. So notice that the degree is not always that first term that you have here. It's always the highest one. So in this case, we have 8 as our degree. And then our leading coefficient is going to be what? -4. So I, again, copied, paste, and I didn't change the 3. But it should be a -4 here. So my behavior is an even degree and a negative coefficient. So that's going to look like this middle term. Okay, so we say that the graph will fall right and the graph will fall left. And then the last one, f of x equals negative, parentheses x cubed plus 9x squared plus 8. So here could be tricky, right? The degree is going to be what? 3. What about our leading coefficient? Is it a 1 or is it a -2? Because you would have to multiply the -2 into the parentheses, and if you did that, then you would end up with -2x cubed. Okay, so the behavior for that is going to be like the last one. So the graph rises left and then falls right. Okay, so that's how we determine the end behavior. Now the other thing that we want to look at is how do we know when a graph crosses? So if you notice here, the graph is crossing through the x-axis at each 0. Okay, and then on the middle one, the graph comes up here, it touches my 0, but then it turns and falls back down. And then it goes back up and it crosses. And then here it's crossing, but then it touches and turns, and then it crosses. Okay, so how do we know when the graph is going to do that? And so to understand, I put these here so that we could see them, but to save a little bit of time, I'm going to tell you when it happens. I usually like to ask people to observe the graphs and then try to figure out what is happening here. But if we look at the first one here, we have x equals 2, x equals -1, and x equals 4. And they all crossed here, okay? But over here, we had x equals -2, x equals 2, and x equals -2. So at x equals 2, it crossed, but at x equals -2, it touched. So if you notice here in my zeros, I have the -2 listed twice, okay? So if you have an even multiplicity, and you're going to see that word, the multiplicity of a 0 is just really asking how many times does that x equals -2 appear? And we have it twice, right? We have 1, 2, and the number 2 is not the number 2 that's the 0, but the number 2, the number of times that it appears is even, so it's going to touch. But if it appears only one time, like these 3 here, then it's going to cross. Okay, so if we look at this one, -2 appears one time, x equals 0 appears twice, so that's why it touched here. Okay, so let me give you an example. Again, if you forget the multiplicity of zeros, if you remember these two graphs, then you can always remember what they are. If I was to find the zeros, that means I'm solving for x. So 0 is equal to x squared. I can write it as 0 equals x times x, and then 0 is equal to x, and 0 is equal to x, because I have 2 here. So we say that the number 0 occurs twice, so we say the multiplicity is 2. And since the multiplicity is an even number, that's why the graph is touching and turning, okay? But if you look at the x cubed, we can write it as x times x times x, and that's going to give me 3 zeros. And so the 0 appears 3 times, so we say the multiplicity is 3, which the number 3 is an odd number, and that's why it's going to cross, and then it's going to cross the x-axis. Okay, so let's see if we can do an example here. So this is what you're going to see on your homework, right? It's going to say find all the real zeros and determine the multiplicity of each 0. Okay, so the first important thing here is to find the zeros. Okay, so they're telling me to find the zeros. So in order to find the zeros, remember that the first thing you have to do is let y equal to 0, which is right here. Okay, and then since this is a 2, the highest exponent is a 2, this is quadratic. So you can either choose to factor, or you can use a quadratic formula. So I'm going to test the factoring. And -1 is going to work here. So x minus 1 times x minus 1 gives me x squared minus 2x plus 1. I can use the zero product property, which tells me I can separate these two into separately. So I have x minus 1 equals 0 and x minus 1 equals 0, solve for x. So x is equal to 1 and x is equal to 1. Okay, so what is the multiplicity of that 0, x equals 1? So in another terms, I'm asking, how many times does the number 1 occur in our solution here? Twice, right? So we say that the multiplicity of x equals 1 is 2, which is an even multiplicity. And since it's even, that means that it's going to touch, okay, and turn. So the 0 at x equals 1 occurs twice, so therefore the graph would touch and turn at x equals 1. And so here's the graph. Here's your 0, and then the graph comes down, it touches, and then it turns, okay? Here's another one. So the first step, let f of x equal 0, right? Since we're trying to solve for our zeros. And this should really say, instead of f of x, it should really say f of t, okay? So this x shouldn't be there, it should be a t because we're working with the variable t. And then it looks like I have a different problem here. So let me cross this. Let me just cross this out for you guys. So let's not look at this here because it looks different. And let's focus on this one here. So you guys can see it's a little different. So we'll work with this. Okay. So let me go back. Okay, so we have t to the 5 minus 6t cubed plus 9t. So the first thing you want to do is let y equals 0. So here's my 0. And notice that all three terms have a t in common. They have one t in common here. So what happened here? Let me go to the next page here because this is, okay, so let's do the top one because I guess it's, okay, yeah, let's go from this page because the other page had a mistake in there. So here we have a 0, but notice here that the t to the 5th and the t cubed, and this should be a t squared, okay? They all have, well, now I'm confused. Let me just work it out because I have two different problems going here. So let me just get my pencil and I'll work it out here. And let's just do this one here. So we have 0 is equal to t to the 4th minus t cubed minus 30t squared. Okay, so as you can see here, finally, so I apologize, we have t to the 4th negative t cubed and a t squared. And all of these have at least a t squared in common, so we can factor out. Let me get my pencil again. We can factor out a t squared from the parentheses. So if I take a t squared from the t to the fourth, I'm left with a t squared. And if I take a t squared from negative t cubed, I'm going to be left with a negative t. And then, so a negative t here. And if I take the t squared out from the negative 30 t squared, I'm left with a negative 30. Okay. So if you notice, in the parentheses, I have something that's quadratic, so we can try to factor that out. So we're going to have t squared is t times t. And then two numbers that give me a 30 would be, there's a lot of them, right? There's 15 times 2, there's 3 times 10. But the ones that I would think about first is 5 times 6. And the reason I like 5 and 6 is because if I add and subtract, it would give me that 1 that I need in front of the t. So let me go ahead and put a 5 and a 6 here. And since the 30 is negative, 1 has to be negative and 1 has to be positive. So since my t is negative, that means that the bigger number should be negative. Okay. So now I have my three factors, so I can set each one equal to 0. So I have 0 is equal to t squared. And then I have t plus 5 is equal to 0. And the last one is t minus 6 is equal to 0. So for this answer, I get t is equal to 6. And for this one, I get t is equal to negative 5. And what about this one, 0 equals t squared? What do I get there? And so depending on how you solve it, we do get t equals 0, but just be careful with that, because if you do this and you're taking the square root, then you say t equals 0. And I see this happen a lot, right? So then we move on with our lives and everything, and it's incorrect. This is actually, remember, t squared can be t times t. So you have 0 is equal to t, and 0 is equal to t. So you have two zeros that are appearing here. Okay. So your degree is a 4. So you should have 4 zeros, which we do, 1, 2, 3, 4. But the multiplicity of 0, we say, is going to be what? So the multiplicity for 0, since it appears twice, it's going to be a 2. So that's going to be even. So at the graph is going to touch and turn at t equals 0. But for t equals 5, negative 5, and 6, the multiplicity is 1. So the graph here is going to cross and cross. Okay, so I might have a graph for this, but let's check, because it had two different equations here. Let's see. Oh, look, if I would have gone one more page, the problem was actually correct on the next one, right? Okay. So we already talked about that, right? So we got our zeros. So if you notice here, I have the graph. So I'm glad I have the graph here. So we got t equals 0. We got t equals negative 5 and t equals 6. So if you notice at negative 5, the graph is crossing. And then at 6, the graph is crossing. But at t equals 0, the graph came up here, it touched, and then it turned. Okay. And so whether it crosses or touches is dependent on the multiplicity. So the number of times that the 0 occurs. Okay. So let me go ahead, and I have 5 minutes. I think I can get through this one, and this will probably be the last one. So one of the things you have to do is sketch the graph. So the first thing that you want to do is identify the end behavior. Then we're going to find the zeros, find the y-intercept, and plot additional points. So for the end behavior, you have an odd degree with a positive coefficient, leading coefficient. So the graph is going to rise to the right, and it's going to fall to the left. To find the zeros, we let y equals 0, and we're going to solve for x. So notice they have x squared. They have x's in common. So I can factor out an x squared from each of these terms. And I end up with x squared times x minus 3. And then I can use the zero product property. 0 is equal to x squared, and 0 is equal to x minus 3. So my zeros are x equals 3 and x equals 0. But remember, this is squared, so that means that the 0 is occurring twice. So the multiplicity of x equals 0 is 2, which is even. So my graph is going to touch, and it's going to turn at that point. And the multiplicity of x equals 3 is odd, so the graph will cross. Then the y-intercept is we let x equal 0. So if I plug in 0 for all my x's, I get 0. So my y-intercept is at 0, 0. So all these three things we need to start our graph. Once you have these three things, then we can start by plotting your zeros and your y-intercepts. So here's my 0 and my 3. And then we're going to apply the end behavior. And if you have a pencil, I would encourage you to use a pencil because you might have to erase a little bit. But the behavior, all we know is that the graph rises to the right. So therefore, I put an arrow going up this way, and it falls to the left, and I put an arrow going this way. But I also know that the multiplicity at x equals 0 is even. So I know that my graph is going to touch here, and then it's going to turn this way. But at x equals 3, it's odd. So I know that the graph is going to go through the point. So that's all I could do for now. But now I want to know what happens in between. Okay, I need to know what is going to happen in here. Okay, so in order to figure that out, we need additional points. And the additional points you can pick are between the zeros here. So if I plot f of 1 and I let 1 equals x, so I have 1 squared minus 3 times 1 squared, that's going to give me a negative 2. And if I have a 2, I get 2 cubed minus 3 times 2 squared gives me a negative 4. I plot those points, and if you're really curious, you can even try 2.5. Okay, but if I plot those points, then I can see that the graph is going to fall down this way, but it's going to come here, it's going to touch the 0, then it's going to turn, and then it's going to come back up. Okay, so that's how we would graph this polynomial. Now for next week, what we're going to do, and this is my sketch. You can see it looks really sketchy. And then here's the decimals graphing calculator graph. It looks a lot neater and prettier, but just so you could get the idea of how you would do it. So next week, we are going to go into more detail about like finding the zeros. That's going to be one of the big topics. And so I encourage you to come out and get to see more examples of that. And make sure that you do sign in to the link. I know there are several links that have been coming through, but make sure you use the, for sure, if you're here to get credit for your teachers for attending, if you want your teachers to know that you attended, make sure that you click the one where it says to use the code word BOOM. And because if you don't sign up on that one, then your teacher is not going to be notified of your attendance. So make sure that you are signing on to that one if you want the credit for being here in the happy hour. But thank you for coming. We enjoy being here helping you all. So if you have any questions, we do have our tutors in the tutoring room that you can ask questions. You can always email us as well. I'm going to put my email here because I have never put it actually, even though you could find me online. But if you need any help or if you need additional videos, you can always email me and I'll be happy to provide some more for you. But again, thank you, Mr. Carizales. Thank you for being here today with us. And if you have any questions, or Mr. Carizales, if you have anything you want to add, then go ahead. And if not, then have a great weekend.
Yes, everyone, have a great weekend. And I also put my email on the chat, so you're welcome to also email me if you have any questions or comments. Thank you all for joining us.
Please join us again next Friday, February the 25th For the next Happy Math Hour at 3 o'clock, our Math 1314 section will be covering synthetic division and complex numbers, and the Math 1324 will be covering solving exponential and logarithmic equations. Again, it's at 3 o'clock every Friday. And please know that our online tutoring is open now and available 7 days a week from 9 a.m. until 11 p.m. Monday through Sunday, or face-to-face tutoring is also available Monday through Friday, 8 a.m. to 5 p.m. Thank you so much, Ms. Chuka and Mr. Carizales, again for presenting today. Thank you, audience, for coming and being a wonderful audience, and we will see you again soon. Have a wonderful weekend.